Alright, so we didn't get to the start of this problem in every class yesterday. So we're going to start with the start of this problem. So you might have this one done if you were in my first class. We got through there, but otherwise we didn't. So suppose the population of San Jose is following an exponential growth pattern. In 1990, the population of San Jose was approximately 782,000 people. And in 2000, it grew to approximately 895,000 people. Let's create two ordered pairs from those two given pairs. So, what do we think our two ordered pairs could be? What do we think our two ordered pairs could be?
One could be... Wait, are we starting at 1990 or...
That's a good question. Do you want to start at 1990?
Sure.
Okay, why? What would be advantageous of us to start at 1990?
Because that's our first known point.
Okay, and if we didn't start at 1990...
We have to go all the way back to like 0 and mankind.
Exactly. Well, mankind has been around for a while, but when so the nice thing is the x value, because that's going to be our x value, right? The x value is going to be smaller if we start at 1990. So if I say that 1990 here is year 0, okay, that's fine. Then all my x values are going to be years since 1990. Okay? Alright? So 0, comma,
782,000.
could we make that be smaller too?
782.
Instead of 782,000, we could just make it 782 and then say we're in thousands. Right? Okay? So we can tweak our numbers just a little bit. And then we would have to say, so T now is years since 1990, and P is population in thousands. Okay? And that brings our numbers down a little bit smaller. Okay? So we don't have to get such huge numbers out there. Given that fact, what would my second data point be? 10, 895. Oops. Use the above data to find an exponential model in the form P of t equals a times b to the t power, where t is the time in years, and a represents the initial population, where t equals 0. Okay? What's up?
Could you only do that where you like did population in thousands when it's like the first three numbers, like whole numbers and then the zeros after, or...
So like Wausau, let's say. Well, I'm just guessing here. Let's say Wausau is 44,432 people. Okay?
Yeah.
So then it would be, let's say we're starting at year 0. So it would be 0, 44.412. You just divide that number by 1,000.
Okay.
Yeah. Mm-hmm. And likewise, as we're going through this, and we get a number that's got a decimal on it, and we're talking about population, we would just multiply that by 1,000, and that would give us the actual one. Okay? Yep, good question. Okay? So, we want a P of t equals a times b to the t power, where t is the time in years, so that would be years since 1990 now, and a represents the initial population. So what would my a value be? 782, because that's where t is equal to 0 already. So I already know that A here is equal to 782. So P of T is going to equal 782 times B to the T power. Okay? But I need to find what B is. Okay? So I'm going to use the second data point. Okay? I'm going to use this data point now to figure out what it is. So P of T would be 895 equals 782 times B to the 10th power. Okay? So first thing that I would do is I would divide both sides by 782. So we get 895 divided by 782 equals B to the 10th power. I want to solve for B, so I'm going to take both sides to the 10th root. Okay. What do we say it was? 895 divided by 782. 1.01359. 1.01359. Right? Did I say that right? 1.01359. 59 is my B. So my function then can be written as 782 times 1.01359 to the T power. According to the model, what would the approximate population be in the year 2005? So how many years after 1990 is 2005? 15. So I'm really finding P of 15. So that would be 782 times 1.01359 to the 15th power. Tapped brakes. 782 times 1 point, actually let's just go like this, times my answer raised to the 15th power. Now, here is where that comes, your question comes back into play. So I get 957.483, right? So that tells me then, if I multiply by 1,000, because our answers were in thousands, that gives me 957,483 people that live in San Jose. Okay. Sketch the graph of the population growth model. Label my axes with words. Okay, well, it's going to start out up here, and it's going to go like that, correct? Because it's a growth. How do I know it's a growth? If it was an E, that would be the case. How do I know that this is a growth?
The B is greater than 1.
The B is greater than 1. Yep. This is in that first case that we were learning about the other night. Okay, so then I need, because it says label my axes with words, so this would be, we'll go with numbers too. So 0 here, and then we can go 5 and 10 and 15 and so on and so forth. So down here would be time, or actually let's just say years. After 1990. And then we can go here and we can say that this was 782, and then 15 would be up here, so then up here would be, we'll call it 957, and then this label would be population, and then I'd have to say in thousands. Okay? That's a nice, properly labeled graph, which some of us have struggled with all year long. Okay? Assuming the population continued to grow according to this model, in approximately what year did the population surpass 1 million people? And it says solve graphically. So let's go graphically. Whoops, that's not graphically. That's graphically. I'm going to start a new page. My page is going to be a graph. My function is going to be 782 times 1.01359 raised to the x power. And that's going to give me that. Okay? Can't see a thing, can I? Because I'm only going up to 66,000 people. Actually, not even. I'm only going up to 6,600 people. So let's adjust my window. So, x. Do I need to go 10 years back? No. Okay, so let's go. I still like to see my axes, so let's go 5 years back. Do I need to go 10 years into the future? I need to go even more than 15, right? Because at 15, I'm still not at 1 million. So 20. So let's go 25 just to be safe. Okay. We'll go by 5s. Okay. Why min? I don't have to really see the bottom, but I do like to see the bottom because I like to see my axes. And how high do I need to go? I need to go to at least 1,000 because 1,000 in thousands is 1 million. So let's go up to 1,100. And we'll go here by hundreds. Okay? So there it is. Okay? But I want to know when it's going to cross over 1 million. So I'm going to add in another function that is 1,000. Because 1,000 is really 1 million. 1,000 thousands is 1 million. So that gives me my, this down, bring that down. Now I can analyze my graph, find my intersection. Whoa. Whoa. Okay. Analyze my graph, find my intersection. Come on now. Why is it not? Working this smart board. Third time's a charm. Or not. Third time's a charm. There it is. Okay? So at 18.2 years, it's going to surpass a million people. Okay? So 18 years would be what? 2008? So sometime in 2008? Okay? Really, we could do, if we really wanted to get technical, we could go 0.2 times 12, and so really it would be in sometime in February, mid-February of 2008. Okay. So, what I want you to do now is I want you to create an exponential model for Columbus, Ohio from the following data and use your model to find when the population is going to exceed 800,000 people. Go. So, there it is. You lost it. Come apart. I get this point here would be 0,633. This point here would be 10,711. Okay? So P of t is going to equal 633 times b to the t power. So 711 equals 633 times b to the 10th power. 711 divided by 633 is b to the 10th power. And then take the 10th root.
How do you do that on like the scientific?
Scientific? Yep, you take it to the 1/10th power.
So like you take this for.
No, so you would raise it, so you got the little caret key, okay? So you got this little caret, so you would figure out, so you go 711 divided by 633, and then I hit equals. And then I would caret it to the 0.1, or caret it to the, open parentheses, 1 divided by 10. The kicker is you gotta have that in parentheses.
Okay.
And then you get that.
You can also go, you can write 10 second, and then it's the one that has the
Oh,
X
yep,
next
this
to
one,
it.
that is second of that one too. Yep, but you gotta put the 10 in first. Okay? So we get a b value here of 1.01169-ish. Okay? So P of t is going to be 633 times 1.01169 to the t power. Okay? And then if we graph that, so we have 633 times 1.01169 raised to the, in this case I'm going x power, gets me that. And again, my menu, I'm going to have to get my, oops, tap the brakes, this one, that one. Good there. I need to go out at least 25-ish maybe years. Whoa, where'd that go? Not 1,025. 25, I like to go by fives. I like to see it, and I like to, so we're going to have to go up to at least 800. So let's go 900. Okay, so there it is. And then I want to put in one that says 800. And there it is. And then I want to find my intersections. Now let's see if I can do this from the, nope. Come on. There it is. So that got me 20.1. Okay? Right? So 0.1 times 12 would be sometime in January of 2010, because it's 20 years after. With what? With logarithms? So we set this equal to 800, because that's when we want it to be, right? 633 times 1.01169 to the t power. Okay, so we divide this by 633. Right? Okay, and then, so now I have it in exponential form. I want to switch it to logarithmic form, so that would be log of my base. Well, my base is that of my argument equals my exponent. And so you'd have to use change of base formula. If you had a graphing calculator, then those you can just type it in right as that. But if you're just on a regular old scientific one, it would be log of 800 divided by 633. Make sure that those are in parentheses. Divided by log of 1.01169. And you should get somewhere down here, it should be 20.1495.
How do I type that into my calculator? Like I have a log, but how do I get to go?
You don't. You gotta use change of base. So you do this one. Yeah. You take the log of that one divided by the log of that one.
Cool.
Yep. Okay. So, what this one's asking now is, so I have it in my general exponential form. I want to put it into E form. General equation in exponent, or with base E. Before I cut my hand off. Okay. Suppose f of x equals 3 to the 2x power. Okay. So 3 is my a, right? So that's where this 3 comes from. Okay. So then we can divide both sides by 3, and that gives me 2 to the x equals e to the kx power. Okay. Since the exponents are equal, okay, the exponent here is equal to the exponent there. We can set the bases equal to each other, so we get 2 equals e to the k power. And how am I going to solve that for k? Now it's natural log. Yep, I'm going to switch it into logarithmic form. Okay, so I switch this over into logarithmic form, and it would be log base e of 2 equals k. Well, this whole log base e business right here, that is the natural log of 2 equals k, which should be on any scientific calculator, should be a key. On the graphing ones, it's the inverse or the control of that one. Okay? And so we get the natural log of 2, which is 0.693147. Okay. Now, logic. I'm a very logical type person. Okay? Logic tells me that 3 times 2 to the x is what kind of exponential function? This one right here. 3 times 2 to the x. It's a growth, right? Because, no, base is bigger than 1. So f of x is an exponential growth function because my base, b, is bigger than 1. G of x is an exponential function with base e. Is it also a growth function? It should be because we set them equal to each other, right? Okay. Does this k value give me an exponential growth function? Yes, because it's positive. Okay? Inverses to solve some equations. How do we solve the following equations? Well, x squared. How do we solve that? X squared equals 9. How do we solve that? Square root both sides, right? What do I get as an answer?
Plus or minus 3.
Plus or minus 3. What about the next one?
Plus or minus the square root of 10.
Plus or minus the square root of 10, yeah? What about those two? What? Unit circle, okay, so where is sine equal to a half? Oops, sorry, I gotta put it back up there. Took it down to write stuff on the board. Pi over 6 and 5 pi over 6. What about 2/3? How would we do that one? Okay, so we know it's up top on the unit circle somewhere. So it's okay. It's not 1/2. It's not on the unit circle. So how can I go about finding what it actually is? Wouldn't need to. Drawing a triangle? You're going to do the same. I mean, you're really talking the same thing of how you actually would do it.
Inverse sine.
Yeah, you could use inverse sine because we're finding the angle. So we could draw the triangle, but it really doesn't help us. The triangle only really helps us for side lengths. Okay? All right? So this would be the inverse sine of 2/3. Right? Okay? Well, inverse sine. Whoa. Whoa. Come on now. I don't want hints. I want inverse sine. Wow, I'm going funky all of a sudden. Of 2/3. I get this, but that's in radians. Times 180 divided by pi. I get 41.8 degrees. Is that the only one? That's the quadrant 1. Right? What's the other one? 138.2 degrees. Okay. What about those ones? X has got to equal 2, right? Because I need an exponent that gets me 9. Okay? So that one's got to be 2. 3 squared is 9. What about 3 to the x equals 10? I got to use logs. So then this would become log base 3 of 10 equals x, which, logic again, should be between 2 and 3, right? Should it be closer to 2 or should it be closer to 3? Closer to 2. It should be like 2.05-ish or something like that, because it's the next one up. Yes, ma'am?
You would punch it in as log 10 divided by log 3.
On that calculator, yes. Yes. On a grapher, I could just do log 3 10, 2 point, oh, I was off. I tried. I failed. The last sheet on your blue packet is homework. You should do it over the weekend. Have a great day.